This video is about central symmetry. This can also be thought of as symmetry through a point. Our coordinate plane is made up of lots of points, and we can use those to reflect points and shapes through central symmetry. So here I have an object. It's a triangle. It has 3 vertices. They are located at 3, 2, 7, 2, and 3, 6. And in this question, I want to find the image of this object under, which just means using, SO. Now we're slightly familiar with this notation from before. The S just means symmetry, and in this case, O just means the origin. Don't forget, the origin is this point here. When I want to find an image under central symmetry, what I'll do is I will take each vertex from the object, I'll bring it to the center of symmetry, my point, and I'll bring it out the far side by the same distance. In this case, my resulting image will be located here. I can see that its vertices are located at -3, -2, -7, -2, and -3, -6. If I compare the vertices of the object with the vertices of the image, I'll see that the only difference is that I've changed the signs. And that will always occur when we use symmetry in the origin particularly. But I can use central symmetry in other points as well, not just the origin. So here I have another example. This time my object is again a triangle. It's located over here in the second quadrant. And in this question, I want to find its image, so where it ends up, under central symmetry, so using central symmetry, in the point 0, 3. So the first thing I'd like you to do is identify where is the point 0, 3. So 0, 3 is located just here. To figure out where I should end up for my image vertices, I'll take each vertex of the object individually, and I'm going to start with this vertex here. I'm going to take my ruler and I'm going to line it up between my point, my vertex, and the point of symmetry. And I'm going to figure out how do I get from the vertex to the point of symmetry. And in this case, it's really easy. I just go 3 boxes across. So I continue on past the point of symmetry out the far side by the exact same amount. So out 3 on the far side also. So now I found the image of that vertex. Now I must repeat that for the remaining vertices from the object. So for example, this vertex. So I'll look at its journey over to the point of symmetry. And I'll see again that in this case, it's actually pretty straightforward. It's a straight line, 2, 4, 6, a distance of 7. So I'll go out a distance of 7 on the far side as well. So I have my second vertex image, if you like. Okay, I have just this guy remaining. So I've lined up my ruler from my object vertex to the center of symmetry, that point 0, 3 that we spoke about. And I want to see how do I get from that vertex down to 0, 3. Well, maybe the easiest way to think of it is almost think of it like rise over run. So to get to this point 0, 3, I have to go down 4 spaces and across 3 spaces. So I'm going to repeat that on the other side of the point. I'm going to go across 3 spaces again and down 4 spaces to land on my new vertex. So just to visualize that one more time, I went from the object vertex down 4 across 3, and then to get to my image vertex, down 4 across 3. A lot like rise over run from the equation of the line chapter. Now that I've found the images of the vertices, I want to get the image of the full shape, the full triangle. To do that, it's very straightforward. I'll just join those vertices together. And I end up with this triangle here on the right, which is my final image. Notice that when I get the image of a shape under central symmetry, the effect is that it's flipped over and rotated as well. So it's almost like a reflection. It's upside down and back to front. But we won't always have a coordinate plane on which to do central symmetry. Sometimes we'll just be given an object and a point on a blank piece of paper and asked to construct the image. This is more straightforward even than axial symmetry. All it requires is a ruler. So here we have an example. On the left, I've got a quadrilateral ABCD. I've got this point E. And the question says, construct the image of ABCD under SE. Here, SE just means symmetry in the point E. So as I said, all we require for this construction is a ruler. And what we're going to do is we're going to measure the distance from each vertex of my object on the left-hand side to the point E, and then we're going to go the same distance out the far side. So I've lined up my A vertex carefully with my E vertex, my E point. I can see there's a distance of 6.4 centimeters in this case. I'll double 6.4. That'll give me 12.8. And I'll draw a line that is 12.8 centimeters long. And this line will end at the image of A, which I can call A dash. I now repeat that for the remaining points from the object. So I'm going to measure from B over as far as E. Again, be really careful, as exact as you can possibly be. Here I see that my distance is 6.7 centimeters. So I'm going to draw a line that is twice that. 6.7 by 2 is 13.4. So I'm going to draw a line that is 13.4 centimeters long. Now that came from B. So it's going to result in B dash, the image of B. Okay, 2 more points to go. C, I'm doing these in alphabetical order, by the way, but you don't have to do them in order. You can do them in any order you like. So C as far as E is 4.4. I'm going to double that. That's 8.8. And I'll draw a line 8.8 long. That came from C. So it's going to terminate at C dash, the image of C. I have 1 more point to go. I'm going to draw a line from D to E and then out the far side. So I'm measuring how long that is. And in this case, it is, I would say 2.3. Again, be as careful as you can with your measurement. 2.3, so I'll double that, that's 4.6. So I'll draw that. And again, that terminates at D dash, which is the image of D. And my final job then to get the overall image of ABCD is to join up all those vertices. And I should see in my image that the shape, the quadrilateral that I started off with, has been flipped upside down and back to front. It's also important that I make sure to join the points in the correct order. So I won't just randomly start drawing lines between these points. I'll look and I'll say, okay, well, A was joined to B and D. So A dash must join to B dash and D dash. I can see that D was joined to A and C. So I should join D dash to A dash and C dash. And finally, I can see that C was joined to B and D, so I should make sure that C dash is joined to B dash and D dash. And here I have my final image then, which is the image of ABCD under central symmetry in E. If you're required to answer a question like this, do show your construction lines.